Hi, this is Lisa. In this video, I'm going to continue a discussion about functions. In our first example, we're asked to determine whether the relation is a function, and then give the domain and range for that graph. So when I look at this graph, I know, even though they're not drawn here, this implies that my graph continues infinitely in both directions. It's the graph of a line. So when asked to determine if it's a function, I can use my vertical line test, and any vertical line that I draw crosses that line in exactly one place. So yes, it is a function. There's no vertical line I can draw that will cross that line more than once. My domain. Now it continues infinitely. As I go out towards the left, this line is going to keep going on. So my domain is going to go towards negative infinity. And to the right, my graph again continues on, so it goes towards infinity. My range, as I go to the left, the graph continues to go down towards negative infinity and up towards positive infinity. So domain and range for this graph both happen to be negative infinity to positive infinity. Use parentheses when you have infinity and negative infinity because you cannot be equal to infinity. There's always another bigger number. You can always go one more and get bigger. So we cannot be equal to infinity and negative infinity. That's why we're using parentheses there. In example number 2, we're again asked, is this a function, yes or no? So I can kind of use the grid marks on my graph here, and each point is on its own vertical grid mark here. So any vertical line that I draw is touching exactly one of those points. So yes, this is a function. It would not be a function if any one of these lines had 2 points that corresponded to it. When we talk about domain and range, domain, remember, we're talking about all of the x values. So I have to look at my grid and where my points are. This point looks like it's at -4. This point looks like it's at -2. This point looks like it's at +2. That looks like 4 and 5. And I use commas to separate my numbers and set braces, these curly braces, to designate that it's just that set of individual numbers. When I look at the range now, I'm going to look at my y values. And for domain, we always did the smallest, or the one to the left, first. When we do our y values, again, we're going to start with the smallest one, this time the lowest y value. And it looks like we're starting at -3, 0. This looks like 1, 2, and 3. So if you have to, like I've done, and I've kind of marked, going over from my point to the y-axis to determine what the values are. But again, I've gone from the smallest to the biggest, or I've done them in ascending order. On this graph, we're asked to determine 4 items here. The first one being f of -2. So what this is asking for is, what is the y value when x equals -2. So that's using our function notation, right? F of x. So where is x equal to -2? There's my point. That looks a little off. There's my point right there where x equals -2. And my y value happens to be 0. So f of -2 equals 0. The domain. Remember, this is the set of all x values, and since I have individual points, I need to look at what x values correspond to all of those. It looks like -4, -2, looks like this is at 2, 4, and 5. any x value for which f of x equals 3. So this one, this is actually telling me this is the same as saying when does y equal 3. So we're looking for the x value. When y is 3, if I find 3 on my y-axis and I go across to the right or left, I've got a point there, and that corresponds to an x value, looks like when x equals -4. And my range are all of the y values that I have. So again, if I go across from each of my points to figure out where is that on the y-axis, it looks like I have -3, 0, let me write these down, -3, 0, 1, 2, and 3. And that's the range for this particular function. So when you're finding the domain of a function without the graph, it says if the function has only positive integer exponents, the domain is the set of all real numbers. And we write it with set braces, the set of x, and this little vertical line means such that x is a real number. If the function has a fraction with x in the denominator, the domain is all real numbers except numbers that make the denominator equal to 0. So we're going to do some examples here. Example number 1. I do not have a fraction, and all I have are positive exponents here, x raised to the second power. So this tells me my domain is the set of all x such that x is a real number. And I'm going to abbreviate here. In example number 2, again, my exponents, when I look at the exponents, positive integers, if it's not written, it means to the first power. 1 is a positive integer. So my domain on this function, set of all x such that x is a real number. Example number 3, here we have a problem with a fraction. And rule number 2 here up at the top of the screen said, if the function has a fraction, the domain is all numbers except numbers that make the denominator equal to 0. So we need to know where is the denominator equal to 0. So where does 4x plus 2 equal 0? Subtract 2 from both sides, and that gives us 4x equals -2, and to get x by itself, divide by 4, and that gives me x equals -2/4 or -1/2. So my domain is going to be the set of all x such that x is not equal to -1/2. And you can say the set of all x such that x is real and x is not equal to -1/2. So it's all the numbers that except numbers that make the denominator equal to 0. And if we look at example number 4. So we've talked about absolute value equations. This is going to give us another one of those absolute value equations. If we set the denominator equal to 0, it means we want to know where does absolute value of 6x minus 2 equals 0. And that's the same as where 6x minus 2 equals 0. So add 2 to both sides of the equation, and we get 6x equals 2. To get x by itself, we divide by 6. So x equals 1/3. So my domain is the set of all x such that x is a real number and x is not equal to 1/3. So all real numbers except the numbers that make the denominator 0. And in this problem, we're asked to use the graph to find the following values. So if you follow along with your notes, what is f of -4? So remember, function notation, this is telling us What do we get when x is -4? So if I go to -4 in my x-axis and I go up to where that function intersects, and I can go across and say that happens where y equals 3. The function value at x equals -4 is +3. F of 0, what happens when x is 0? At x equals 0, if I follow my function up, it looks like that crosses the y-axis at 2. And if we want to know what happens when x is 2, we go back and we look when x is 2, what y value do we get? And it looks like on this one, it's at -3. So you're always, the value in parentheses is your x value, and the y value is also known as your function value. Determine if the graph is a function, give the domain and range. Vertical line test will tell me whether or not this is a function. There is at least one vertical line that I can draw that will intersect that graph in 2 places. If it intersects more than once, it is not a function. Domain. Domain goes from left to right. So the leftmost point I have, and there is a point there at -7. Oops, I don't want my set braces. This is a continuous line, so I want to use a square bracket. I have a point at -7 with a value of x equals -7. And it continues all the way around over here to the rightmost point, which looks to me like it's at 5. And again, there is a point there, so we're going to use our square brackets for including those endpoints. Now, when I look at the range, I have to look at the smallest or the lowest value and the highest value. And it looks like the lowest value is somewhere right around here. It looks like that lowest value to me is equal to -3. And it goes all the way around all of my y values, all the way up to, looks like this point right here has a y value of +3. And again, I'm using brackets because I actually have points on the graph right there. And this concludes the video on functions.